Given 500 feet of fencing, you need to make an equation adding the 4 widths and the 2 lengths, and the equation you need to maximize is the area, which is x times y. And from the 4x plus 2y equals 500, you have to get one of the variables by themselves. So right here I'm solving for y in terms of x. So y in terms of x is negative 2x plus 250. After substituting that y value into the area equation, you come up with negative 2x squared plus 250x for the new area equation. And after that, you find the derivative, which is negative 4x plus 250. Then you solve for the critical points by making the equation equal to 0. And by doing that, you can find that x equals 62.5. And then when you substitute that back into the first equation, 4x plus 2y equals 500, y equals 125 is the value that makes the area the largest. The position function given is t cubed minus 6t squared plus 9t plus 1. And the velocity function is found by finding the derivative of that, which is 3t squared minus 12t plus 9. The initial velocity was found by substituting 0 for t, and that is 9. The object is stopped at zeros, which are 1 and 3. And then the acceleration function is just the derivative of the velocity function, which is 6t minus 12. And the initial acceleration of that, found by substituting 0, is negative 12. This equation can be set to 0 to find the next zeros or where it's stopped. And in this particular equation, they come out to be just 2. Then to find where the object is speeding up or slowing down, you have to make charts of the velocity and acceleration, and you have to plot the zeros, which for velocity are 1 and 3, and for acceleration is just 2. So you plug values in higher or lower than those values, and you see whether the answer is, you plug them back into the original s of t function, and you find out whether the answer is positive or negative. So in this case, the objects are slowing down from 0, 1 to 2, 3, and they're speeding up from 1, 2 to 3 to infinity, or whenever the object stops. To find the distance traveled from time 0 to time 5, or 5 seconds, you have to plot each value from 0 to 5, t equals 0, 1, 2, 3, 4, 5. So but you find the y values by plugging the x values into the equation, and you first find that it goes from t equals 0 at 1 to t equals 1, 5, to t equals 2 at 3, to t equals 3 at 1, to t equals 4 at 5, and t equals 5 at 21. So the total distance traveled is 28. So here you begin with the equation 20 pi equals pi r squared h, and 20 pi is the specific volume that you're given for this problem, and then the material for the bottom and the top cost either $10 per square meter or $8 per square meter. So I substituted 8 for the side material, or I just multiplied 8 by the side material surface area and 10 by the top and bottom surface area times 2 because there are 2. You can substitute H as in terms of R as 20 over R squared. So I substituted that into the cost equation, which ends up with 20 pi R squared plus 320 pi over R squared. Then the derivative of the cost is found, and that's just by finding the derivative, and then afterward you set that equation equal to 0 to find the critical points. By factoring that, you can get r cubed minus 8 and set that equal to 0 because it's in the numerator, and you can find that r equals 2 will make the most economical cylinder. And then that value is substituted into 20 pi equals pi r squared h to find the h value that will make the most economical cylinder with the price boundaries given. So that comes out to be r equals 2 and h equals 5.